All right, everybody, welcome to sig-cluster-ops public meeting. It is July 27th. It's a Thursday, and we are here to discuss all things cluster operations. So the agenda is located at the short URL of bit.ly/Kates, K-8-S-C-L-O-P-S, Kates-clops, if you want to follow along after the fact and watch this video. So without further ado, let's get this meeting going. So we'll start with advisories. There is a discussion underway about etcd2 and how we want to maintain or how long we want to maintain that as a core part of distributions and backward compatibility for that. It raised a really interesting question that is right in our wheelhouse, which is how do we get a full feeling of what the user-facing impact of such a decision or deprecation would mean, which ironically, in Azure Container Service, we are currently using etcd2, so it would probably be landing in my lap among many other people's. So it's a real-world concern. The trouble is that maintaining these backward versions requires a lot of test maintenance and upgrades and constant attention, and it makes the release process ever more complicated, as anybody who's ever dealt with a legacy test suite knows. So that's an interesting discussion, and it's underway on the Kubernetes dev mailing list, and I would encourage anybody watching this recording or attending this meeting to look into that and voice your opinion if you have one about what etcd2 versus 3 means in your production environment, what deprecating that support would mean. And there's an interesting little caveat there too. That doesn't mean that etcd2 will stop working necessarily. It's the ability for the release team to certify that it works with etcd2, because those tests will become stale, or you'll have a lot of rot that may not necessarily indicate the health of the upgrade path. So yeah, that's pretty much it on the etcd2 thing. Anything you want to add?
That's a subtle point, though, right? We're talking about whether or not you keep testing etcd2. It might keep working happily.
Yes, but you never know when it's
shifting the burden to the operators who are using it.
Mm-hmm. Well, and that's an interesting thing too. Is so in prior operational environments that I've managed, I would encourage my team to do their own integration testing, especially where you have things that have package managers installed, or you can pin versions and whatnot. But even then, sometimes stuff gets crazy, and you can break something by having a dependency in your chain that fails. I'm trying to think, like a lot of the stuff around Chef, we had a lot of issues with things being pulled from Chef that would just break the whole build. So that's a pattern. And so having the ability to check, if you're relying on etcd2 and it's not officially supported, you can still spin up your own infrastructure to test that. There's nothing to keep you from doing it, but it's just more convenient to have it be part of the project.
Yeah, it seems like it's a reasonable thing to deprecate it from 1.8 test. Because, I mean, if you're dependent on it, you could be on 1.7. You're just going to not get the features from 1.8.
Right, and that is a thing, for sure.
Yeah, and then that sparked a really interesting conversation about how we actually have this conversation. I quickly went meta.
Yeah, right. And here we are having this discussion about our discussion.
Yeah, without enough operators to
the best way to do it, right? And Radek, not to in any way diminish your input on it, but we definitely need more people than we're getting, attending to be able to have these discussions.
My real concern about etcd at this point would be the question, which I'm not certain what's the state now, if we do have a painless path of upgrade from 2 to 3 on a working cluster.
And the answer from my own testing and doing that is yes, it is a pretty pain-free, non-disruptive upgrade. The thing that I have not personally done is test it with just oodles and oodles of traffic across the key value store while it's happening. I think a quiet cluster leads to a more sane upgrade. So certainly that would be a recommendation, is to do it in a time where you're not getting a lot of production traffic. But you can spin up a cluster on etcd2 and test the upgrade path for yourself and see sort of what you find. But I thought it was great. I mean, I thought it was really well done. The CoreOS folks are very attentive to operator concerns, and they obviously are right in the middle of it with Tectonic. So they do an incredible amount of diligence and care with those upgrade paths, which I tremendously appreciate.
Yeah.
The other part of this equation is actually how it's supported into tooling like, say, COPS. In my case, that's the one I'm using, because my guess would be that until those tools actually support this kind of migrations, for some people, this will be a headache.
They have not crossed that bridge yet. It's not surprising that they haven't, because it is fiendishly difficult to have that sort of upgrade be programmatic, especially since the way that it cuts over. You're kind of watching each node to flip over to the new version 3 endpoint. So it's not just like spin up your new etcd cluster and run with it. So there's a little bit of just watching it go. So I don't know how programmatically they would do that, honestly. So but those people are so smart. They'll.
Yeah. If you didn't design it from the start, it's hard to imagine being able to retro that in based on the tools that I've seen doing installs.
Right. Yeah. Maybe if it was digital rebar, but but we can't all be digital rebar now.
You can't all be there, and actually, I'm not even sure digital rebar is digital rebar in that case.
Cool. Well, let's move on through the agenda, if that's all right with you guys.
Yeah.
So 1.8 feature freeze is on 8.1 or 8.1. Wow, I've been 8.1 August 1st.
That's awesome. You need to do the date is 8.1 like that.
Exactly. Yeah, so that's going to be interesting. I think this is a notable thing, that this is the very first time that a release manager has been a not developer. So this is the first ops person doing a feature or a patch release. So, or not a patch release, but a minor release.
Ooh, that's Tuesday. Yike.
Yeah, I know, it's coming up fast. I can't even.
I'm going to stop my 1.7 activities and wait for 1.8.
Oh, that's the feature freeze. That's not a.
Even so.
All right. Well, you still got a while, my friend.
Yeah.
Don't get antsy. But yeah, so I think this is a really interesting maturity point in the project where there's enough confidence in somebody who's not a developer to actually run the release. So that's exciting. And so as a result, it goes to the next bullet point, which is my availability is going to be slightly strained for the next few months. So unfortunately, Rob, you might be bearing a little more of the weight than would normally hope for. Same is true with community activities. I've had to scale back my involvement with leadership and the sort of UX stuff and Contribex, and also taking notes and whatnot. So I will be available for questions. I'll keep an eye on the Slack channel as per normal, but I probably, just generally speaking, will be less available.
Makes sense. That's cool. Yeah, I can definitely run us through that process. I have since the next topic's one near to my heart, we'll probably focus on that one.
Okay.
Hey, did they talk about, because I had to drop off for a little while, did they talk about the governance board and dates on that?
No, I haven't heard anything. I do know that they are struggling to find time to all be on the same place at the same time to talk things over.
Yeah, summer sort of sucks. It's
really hard, and especially with people on different time zones, and it's tricky.
Yeah, it takes quite a bit. Cool. Noted. I will carve out time to at least keep us on the calendar. At this point, a lot of, to me, the cluster ops priorities are going to be hard to surface until we have some governance board that can help, create some authority around what we're doing.
Agreed.
Although, and hopefully next meeting we'll have Lockie talk about the node admission stuff.
Mm-hmm.
Actually, let me transition to that, and then we can talk about ops and node admission, because I think that there's a chance that there might be some rallying cluster ops stuff around node admission and what's going on with that, because I think that that's potentially unifying in a way that we need. But I'd love to talk about that. So let me. So we've had this sort of, hey, we want to talk about this topic burning in the background for the last couple meetings, and it's around this combination of features that came up with 1.7. And I'm trying to get Mike Denise or Lockie or me to spend some time talking about the actual tech for this. But in 1.7, we moved configuration for kubelet to the API server, so a kubelet can actually get, this is I think it's a beta feature now. You can actually do, if you put kubelet configuration information in the API server, when the kubelet starts, it can air quote self, because it's not self-configuring, but it can pull its configuration from the API server. So you need very little information to start a kubelet in an environment, with two caveats. One is that you've been able to tell the API server that kubelet's coming and give it configuration. And then two, that you can trust that the kubelet, when it shows up, is actually a trusted kubelet, which is what node admission does. So node admission lets you validate that a kubelet coming in is a valid member of the cluster. And so these pieces are coming into the Kubernetes community in a very powerful way. They address a real operational need based on the way I'm seeing people do the deployment. And so it's a combination of some of the kubadmin work that's going on, but also like the node admission stuff, I don't think is kubadmin. I think that's API server work. And so there's this combination of features that creates a much less configuration management approach to installing Kubernetes. And I think it's disruptive because it's so easy. If you start kubelet, start a machine with kubelet and a little bit of information, then the cluster is going to build itself, is really the goal. Does that make sense?
Does it also reconfigure on the fly?
In what sense?
I mean, I don't know what extent of setup you can put into the what you can have inside of the Kubernetes API, but I assume that you might have, I don't know, things like let's say a path for the static manifests, because it's simple, and let's say you want to change it for some reason, whatever. If you change the configuration in the API, would this configuration be reflected on the kubelet like while it lives, or if it reboots, or?
I'm not sure. These are the questions that we want to have, get the right people in the room for, and it might take multiple. So if we can find the people who can answer that question, I want to get them to cluster ops so we can ask them questions and record it.
Yeah, I don't think that's the case. I think it's a bootstrapping mechanism, not like a config map or something that's dynamically changed. But again, yeah, as Rob said, we need to get people who are busily coding this feature out to drive that conversation.
And my expectation is the pattern that they're driving is that you would never reconfigure. It's always destroy and recreate. So the idea that I would expect a node to absorb configuration changes after it's been installed is would it's not exactly an anti-pattern for what I think people
That makes sense.
and for me, who has a metal bent on this, the idea is that we're talking about servers that are being flipped and reimaged with immutable operating systems, and so there's a ton of drive that I see in community where people really want to have this. I boot a machine, the cloud init has the information to join, it does it, and then if you wanted to make the type of change you're describing, you would make the change and then recycle the node.
Sure.
And the consequence is that all of a sudden, a lot of the install processes that we've been working on, these, there's a couple of the Ansible ones, some of the salt process, they seem not as material, right? You need something to bring up the cluster, but after that, adding nodes with an auto-scaling group seems like a couple lines of bash or a couple lines in a CloudNet file.
Yeah, that's an interesting paradigm shift. It's, and seeing this, the new Microsoft stuff is the container instances and the ACI connector is even one step further in that direction, right? I think that's where we're going, is completely fungible workload triggered nodes, essentially.
Yeah.
Which means that cluster standup is control plane standup, and then it just needs to know how to marshal nodes or node resources.
Right.
Versus, I have my Ansible config that goes out and spins up 5 hosts, and 3 of those are control plane hosts, and then 2 of those are my initial nodes, and then there's an auto scaling group associated with those that's going to spin them up as they get too busy. But that's not really, I don't think any of us assumed that is a long-term viable solution, because it sort of is an anti-pattern in the cloud to have machines sitting there that are doing nothing, and potentially those first 2 nodes that get spun up from your control plane are doing nothing.
Right.
And how do you scale those nodes to meet the workloads and all that stuff? That's that's anathema to the entire principle around Kubernetes being like workload on demand. So I think that we're really going to see this pattern emerge in a very strong way, where there's much less reliance. It's kind of a race to the bottom about building your cluster, right? It's a race to zero, and that the real challenge is going to be how do you have a stable control plane that's enduring enough, and how do you marshal the workloads in the back end, especially in places like metal.
Yeah, that's where we're going with this is actually, and this is why I was making my joke about rebar not even being rebar for this. The need for orchestration, like we're describing, we see diminishing.
Yeah.
Right. There's no doubt doing this SCD migration that we're describing, somebody needs to be doing orchestration like that, and we've been historically writing it. But most people for most nodes just want, they want a simpler workflow.
Yep.
And so I think that this is super interesting and potentially could drive the Kubernetes community down a path of saying, no, we do it this way. We don't configure a worker. And so we could actually reach a point where, at least for worker adaption, by the I don't know if we ever switch to 2.0, say the 1.10 release time frame, it could be that we actually converge the operational community down to, this is the pattern. You can do it other ways, but this is the pattern that we use for workers. Here's 2 or 3 ways that you can start the control plane up.
Yep. Yeah.
it's 3 nodes. You can follow Kelsey's hardware script and get it done in an hour.
Uh-huh.
But that makes me nervous too. I do think that there are follow-on pieces that I know operators care about around monitoring and performance management and things like that are not that simple in the way I'm describing it, right? If you have nodes that are just being destroyed and recreated, that's going to drive monitoring systems insane. Maybe in Metal, the nodes are going to come back with the same identity over and over again. So a monitoring system's, going to basically be persistent with some gaps. But
Yeah, I mean, I feel like that the sort of ephemeral host problem has been plaguing a lot of cloud implementations for a long time. I remember trying to get Zabbix, to play nicely in a cloud environment. That was I pretty much wanted to just commit suicide at that point. It was horrifying to deal with that. And that really wasn't a good answer. And I don't know that there's certainly like Datadog does a good job with that stuff and other places, but it's still a challenge, right? I mean, there's a notion that's deeply embedded in the DNA of ops infrastructure that things are not, that things are precious, right? And essentially one of the big mental shifts that you get from cloud computing and cloud native and even cloud native principles applied to Metal is the idea that nothing is precious. And
right.
That is really hard. That is really, really hard.
It's going to clearly take some time. I mean, this is what, the reason why you'd want to keep using Ansible to bring up nodes in a cluster is because you don't want to have a fight about it.
That's funny.
And so, bringing up a cluster with Ansible when it's physical nodes, you're like, well, I have 10 nodes. Why would I not just use Ansible to bring up my 10 node cluster? It's done.
Yeah.
But at the same time, I think that there's so much pressure on this approach as the right way, cloud native way that I can see. And so this comes back to the theme. I think over the next 3 months, getting up through the 1.8 stuff, this is actually a reasonable topic for cluster ops to document, get right. I have a lot of motivation to do that, and so that's my expectation is over the next couple of months. That's what cluster ops will be doing. Okay.
Well, seeing as you're going to be the lone cowboy on this for a bit, I think that's probably what'll happen.
Unless somebody else steps up.
Yeah.
Do you know if this is happening somewhere else in the community?
What is this you're speaking of?
Documenting, describing this process. I mean, I think Lifecycle is playing with it, but Lifecycle is still playing kubadmin, which is not this.
Right. Honestly, I have not heard anything to the effect that anybody's documenting this stuff.
Okay. So I'm going to try and wrangle Mike Denise. Do you know, this is a very logistics question. Did you know if he ended up in Portland or Seattle?
I have no idea.
Okay. I'll find out. The reason is I'm going to Portland in the next 2 weeks. So
cool.
I might be able to buy him coffee and say, explain this to me. I need to know it for you. He and I had a very intense, in a positive way, conversation at the Leadership Summit where he was talking about using hardware signing information for the node admission criteria.
Huh. As a requirement or?
No, it's an option.
As an option, yeah.
So this is, and I don't want to belabor the point. We can close the meeting, but the place where Mike got very excited about it, and he said all the right buzzwords for me to get excited about, is the idea that you would sign your hardware, and then the node admission criteria to join the cluster is actually from the hardware encryption modules, trusted modules. So the certificate of the machine is able to validate its existence through the node admission webhooks.
Yeah.
And so in that case, you've simplified when a node shows up and it says, "Hey, I'm here to join the cluster. You can, and here's some information I've signed for you. Validate me." You can provide that as a service. And boy, that's powerful.
Yeah, that is from a regulatory standpoint. That's a huge thing.
Yep. And it's totally possible for us to automate that whole process. I have all the pieces. I just don't have somebody to collaborate and pay. So
yeah,
which is why Mike was like to pull me aside and said, "Look, we need to help people do this." It's a really interesting, and it'll work on Amazon or Google Clouds or or Microsoft, where as long as you have a TPM infrastructure.
Yeah, I wonder because I have to really think that pattern over in a cloud setting.
I'm not sure it's necessary in a cloud setting, right? You at that point you're injecting credentials into Cloud Init, and even that's part of even on hardware, right? We're starting to do Cloud Init type configuration.
Yeah,
and so I can inject. My phone keeps sliding down. I can inject whatever I need into that process, and so it would have the credentials to join.
Right.
Yeah, this is super. It's super exciting. It feels to me like, as much as I've been a fan of the Ansible approach because I think it's very consumable, this feels operationally very simple.
Mm-hmm. Yeah, I'd agree with that. It certainly is. It's a pattern that has been successful in other implementations, right?
It is, well, and it is the cloud pattern.
Right.
So right, we from a cluster ops is not intended to be one or the other. It's meant to be a generic. And so the extent to which we can see this convergence of cloud patterns coming together and then hosted patterns coming together, that's where I get very excited when that Venn diagram drops to a circle.
Yep.
Cool. And I'm still looking for deployments to talk about.
Okay.
If the Microsoft team's willing to sort of open kimono a little bit and talk, I would love that. Or if you run across anybody who's like, all right, I deployed Kubernetes, please just rope them and say, come to ClusterOps and tell us. We want to know. I
definitely will do that. It's funny. I have my role in the company. I'm like 99.9% Kubernetes stuff. Like I don't even really. I have connections deep into the org, and I can get people to do things and whatnot. But really, my first allegiance and duty is to the Kubernetes project. So I don't get a lot of cluster ops stories, except sometimes I'll get customer stories that come through an email and whatnot. But in terms of just like my day to day, I'm talking to everybody in the community. I'm not talking to people at Microsoft.
Well, the community is actually where I'd rather have them surface anyway. So if you find somebody who's like, hey, can you spend 20 minutes telling cluster ops what you did? It gets recorded, and then other people can benefit.
That is a key thing right there, what you just said.
Yeah, the SAP one was amazing. Absolutely.
Yeah, absolutely.
So, all right.
Well, I think that's it, huh?
That's it. We'll work on getting Lockheed next week. Good luck with feature freeze.
All right. Thank you so much.
And I'll wear a sweater for you.
Yeah. It's not cold out here, believe me.
Austin is going to be about 104 that day.
Oh, wow. All right. Thank you, Radek. Have a great day and rest of your night. And all right. Thanks, everybody. Bye.
Thanks, Jason. Bye.
Great seeing you. Thank you.